We are on to the working group update. So for those who don't know, the first section of the talks has been pretty traditional. It's following our established format. But for 2023, we decided to go with a new meeting format that Peter Mattson thought up that is designed to encourage in-person interactions and discussions rather than updates. So we have an abbreviated update section. So each working group is going to give us roughly a 3 to 5 minute update on what their goals are, if you aren't familiar with them, what they've been doing in the last quarter, and then sort of what's on their roadmap over the next 3 to 12 months. The whole idea is not to give you lots of details, but if you are online or you are in person, you will get to see who are the working group chairs, what are they doing, and if it piques your interest, please find them afterwards and talk to them. And, we have a lot of speakers, each doing a short update. So the context switch overhead will be probably high. Some people will be remote. And if that doesn't work, then I'll have to talk through their slides, I guess. So we're going to start with the mobile working group, which is William Chow.
All right. Hi, everyone. Actually, this is the first time we're going first. Okay. I'm William Chow, and I'm one of the chair in the mobile group. I think you met our also new chair as well. So in the mobile group, our main purpose is we are actually developing these actually public benchmarking app that press or public they can download. And we mainly focus on phones and laptop basic devices that are battery powered, because these are some of the devices that people can easily access, and we want them to be able to measure their performance directly from this app. So this is actually something very interesting, because then anyone will be able to kind of replicate each other's result directly on their device. So one of our key update in the since the last community event, because we have the app, so this actually requires a lot of work doing like execution, because we have to make sure the app itself is functioning, that it has to integrate all the framework from all the other SoC vendors, including Qualcomm, Samsung, and also MediaTek. From the last community event, we actually had the also the 3.0 submission, which we do actually have a new model from Seoul National University. And as a mobile group, we do actually make sure we have a like an annual update on the models to make sure that we are actually keeping the model to be relevant. We will actually very soon will actually be able to release the app that will actually be available to download currently in the Google Drive. And that will include a new super resolution model and also adding some of the newer smartphone SoC from MediaTek and Qualcomm. Most important thing, we have additional upcoming feature. For example, we're making sure we're doing testing properly. And also we are also trying to seek out new models as well. And what's importantly, we also have a default runtime, which for even legacy and also lower tier device, you'll be able to get an AI performance number. And last importantly, we're also doing kind of data collection. So then we'll get like a massive amount of public user data that will actually boost up the traffic for the MLCommons website as well. And this is our timeline to save interest. So right now we're looking to expand more in March 2024. So we're also looking at maybe having a kind of a Windows version of the app also available on top of the Android and iOS app, which we have today.
All right. Awesome, William. Thank you for the update. The one thing I want to say personally that I'm super excited about is getting the default runtime will allow the mobile app to run on any device. And so that at that point, we can put it on the App Store, and then we can charge people money and get ads. Oh, sorry, we're not doing that. Right. We can put it on the App Store. All right, Rod, your turn. So while Rod is coming up here, one of the things we're working on is developing an autonomous driving benchmark. We have a task force that is focused on this. And Rod is a graduate student at UC Davis who is helping to lead the effort and is now going to give us a brief overview.
Okay, so the purpose of our working group is we're going to develop a benchmark that's representative of an automotive task for both the training and inference working groups. And our specific goal is a multimodal 3D object detection task. And in this case, the modes are LiDAR and camera sensors. In terms of updates on what we've done so far, we have the data set decided, we have accuracy metrics, and at a high level, we have settled on the model. We're using the Waymo Open data set. We're using average precision heading as our accuracy metric, and we're using a point painting model. And this model basically uses the camera features, uses some semantic segmentation to append the LiDAR points, and then it uses like a normal 3D LiDAR detector. In terms of where we're at with it, we have a working implementation of point painting, but we're only training it on a few samples right now. Training it on the full data set has been a challenge as we need help with getting compute resources. And right now I'm working on getting something that's like on about 10% of the data set. And I'm trying to have it set up so that other people can run and hopefully get help with doing it on the full data set. Some other longer term things we're looking at doing, we are looking for a co-chair for this. So if anyone is interested, they could speak to me or Tom. We're going to settle the details of the model. So we're working with the automotive advisory board and we'll hammer out all the every detail on like, you know, what backbones to use and so on. Of course, we want to train on the full data set. We need to determine an inference scenario based on the changes in some of the inference rules. What we need for auto doesn't quite fit with what's existing. So we're looking at like if we're going to do something separate for auto. And in terms of where we're going to have it ready, we're targeting training 4.0 and inference 4.1.
All right, perfect. Thank you very much. Automotive Benchmarking Task Force. So that is James and Casper. Are James or Casper on the line? I don't think so. All right, so that means I get to talk about this. So James and Casper are the co-chairs of the Automotive Benchmarking Task Force. As I alluded to previously, this is done in collaboration with AVCC. And one of the core ideas here is that we would like to develop a set of benchmarks that can be open industry standard for inference in near-term automotive platforms. What Rod was just talking about is, you know, very focused more on autonomous driving, on challenging training problems. Things that are pushing the very boundary of sort of ML compute. But if you look at what actually goes into production in a car that you might buy next year, it's going to be something that is, you know, probably a little less aggressive, right? So things like lane keeping assist, features like that, we're looking at ML oriented in there. And a part of the goal is to have something that can actually be used to aid and abet commercial transactions, right? Specifically, you know, the automotive industry is going through a process where there's just integrating a lot more intelligence in the cars. And, you know, there's a lot of value if we can get standardized benchmarks to help drive the purchasing process as well as optimization. So we started in February. We are getting close to finalizing the memorandum of understanding between ourselves and AVCC and are looking at the next phase will be a minimum viable product demonstration, followed by a full-on developing the benchmark suite. So things we're looking at right now are, you know, what data sets do we want to use, what models which should be considered, particularly for sort of the minimum viable product, the demonstration phase. All right, algorithms. Frank, you're here. All right, perfect. Do you want to take this over?
Sure. All right. So hi, everyone. I'm Frank Schneider. I'm from the University of Tübingen. I'm one of the two chairs for the algorithms working group. And our goal is to create a set of benchmarks that can measure how fast we can train neural network or how much faster we can train neural network due to algorithmic ideas. So our focus on the working group is not about the hardware or the software. We want to try and keep this fixed. And instead, we want to investigate what speed up we can gain from changing the underlying algorithmic ideas behind it. So very specifically, we have two goals in mind at the moment. There might be more in the future, two very specific benchmarks. The first that we're currently working on is the MLCommons training algorithm benchmark. So here we want to benchmark training algorithms, which broadly just means every algorithm that is involved in directly changing the trainable parameters of a neural network. This is the one that we're working on right now and that we hope soon to be published. And next on, we will work on the model benchmark, which basically flips the question around. So maybe we can not only train neural networks faster by having better training algorithms, but by actually having models that train more easily. So those are sort of the purpose and the specific goals of our working group. And what we worked on last quarter was mainly putting finishing touches on our code base. It's mainly done. We're still doing some minor bug fixing. There's a few workload variants that we still need to implement, which are just slight variations of the workload we had that we want to have as held out workloads. We're currently implementing the last baseline submissions that we want to present for the potential submitters. And I guess the same also holds for the draft of our paper, where we're putting the finishing touches on it right now. So this will be the first paper introducing the rules and the baselines of the MLCommons training algorithms benchmark. So hopefully in the next couple of quarters or month or weeks, maybe even, we can finish this, publish the paper, and publish a call for submission for the benchmark. So here the benchmark is the training algorithms benchmarks, so that in the longer term, maybe we can move on to either the next iteration of this training algorithms benchmark, and hopefully also build the MLCommons model benchmark in maybe the next month or so.
Hello, my name is Sergey. I'm a co-chair of the best practices working group together with Diane. We're sitting right there. So our goal is really to come up with specifications and technology to enable users and machine learning researchers to share their machine learning projects, workloads in a more portable and reproducible way. So we are relying on OCI containers to package their ML projects, meaning that they can use Docker and Singularity containers. And our goal is to essentially make it more simple for them to distribute their projects and also package some of the MLPerf benchmarks. So we start with this initiative of MLCube, which is basically a technology to achieve that. And we've been working on this for probably a couple of years as of now. And a couple updates since last time is we've packaged several MLPerf reference benchmarks as basically as MLCubes. We've done a number of documentation updates. So we have a website and where we essentially provide information about how to use MLCube, how to package workloads, what ecosystem of tools is available. And talking about the ecosystem of tools. So we are providing sort of templates so that users can start their projects right away, cookie cutters of some kind. Then we are providing several reference MLCube runners so that users can take those containers with their ML projects and run those containers in different environments, such as local machines or remote systems. They're accessible via, for instance, SSH. Essentially, in this last quarter, we've been fixing bugs and introducing new features. So we work together with MLPerf and DataPerf working groups. Essentially, we are in this process of basically they are asking us what they want, and we are implementing that, right? And we have a number of updates related to that. We've improved a little bit our project, as I mentioned. So we removed some redundant Python dependencies. We optimized how we use them. We updated versions of these Python dependencies and so on and so forth. One of the ideas behind MLCube is that people can provide runtime parameters, such as what kind of network they want to use, GPUs, memory, and so on and so forth. So we added support. We added a better support for this in this latest release. Right. So what's next? We are writing right now a paper where we are surveying technology, similar technology, and where we will position MLCube as basically one possible way to distribute ML projects and workloads. We are developing more MLCube tutorials, and we are updating documentation to better explain how to use this. We will be packaging more MLPerf reference benchmarks as MLCubes, and of course, we will continue supporting MLPerf and DataPerf competitions. What we plan to do in the next several months is to improve user experience in the first place, to simplify CLI interface of MLCube runtime. We were asked to add Python API so that certain things can be done through Python, like running MLCubes or getting details about those MLCube projects. And another feature that I'd like to mention is that right now, in order to run MLcubed ML projects, we need an external file that explains basically what's inside. And we'd like to sort of avoid this doing in the future. We would like users to be able just to get a container, and then that container is going to be sort of self-explainable. It'll provide information about essentially what it implements and how to run it. Hopefully, we'll be able to do that and talk about this by the next community meeting.
Awesome. Thank you very much. All right, next we have the medical working group.
Hello, everyone. My name is Alex Karagiris, and I'm the co-chair for the medical working group. And today I'm going to be talking about the medical progress we've done so far and an update on the current progress over the past 3 months. Also, I'm going to present new updates on the next few months, as well as I'm going to present the current challenges we're facing as a group. So the group was, I just want to, give the purpose of the group, was established with a focus on developing and supporting benchmarking for the medical AI space. And we're trying to do that, on real world data. And the reason behind it is because validation of machine learning algorithms in general is considered an important step. And extensive validation of medical AI should be also considered, essential. So therefore, the rationale of creating this medical working group arose exactly from the need to provide robust validation of AI on diverse data. So we're focusing on 3 major, goals to support, the mission and the vision of our group. So first one, we have been developing MedPerf, which I'm sure, many of you are familiar, which is an open benchmarking platform that supports periodic evaluation of medical AI algorithms. Second, we have been developing Gandalf, which is a framework that builds on top of popular machine learning frameworks such as MonAI to support, basically zero-low code ML workloads for machine learning, for medical machine learning. And third, basically, our aim is to research and develop benchmarks that have clinical impact. And specifically, beyond just benchmarking ML algorithms on the accuracy and performance, we want to also investigate more soft metrics that measure clinical outcomes, such as bias and health equity. So the past, 3 months have been very busy for us. Finally, the MedPerf paper has been accepted to Nature Machine Intelligence. This is a monumental effort with more than 65 co-authors and a large list of organizations from academia and industry, which participated in this great, effort. This paper would not have been possible without the strong support of MLCommons and certainly commons like Intel, Nutanix. I want to thank Debo in personal for the support, Dana-Farber and UPenn. Also, our paper describing Gandalf has also been accepted in Nature Communications Engineering. So we have basically 2 efforts basically published into 2 prestigious publications. And this is also a big, milestone for the group because it's more than 60 organizations that have contributed to it. From a technical perspective, there have been a lot of developments. Specifically, we have been working closely with the Synapse platform to interface tighter for the purposes of supporting challenges on medical imaging. We also have been working on improving the user experience, as well as adding new features and enhancing documentation for MedPerf. So, and all this, basically leads to support perhaps, the largest federation of medical imaging challenge, and that's the BRATS, FEDS 2023. It's going to be more than 70 hospitals around the world instead of 30 that we had last year. We are also planning to add an interface for federated learning frameworks because this is, a request by participating hospitals. So this is super exciting. A very important focus for this year at MedPerf is to improve the data ingestion layer. Because as you can imagine, as we're focusing on, building this interface with hospitals, we need to be able to ingest, data better. So in particular, we are going to add support for XNAT, which is the largest open research framework for imaging studies. This will enable MedPerf to integrate better with more research hospitals around the globe and also provide better, as I said, data ingestion and pre-processing of the data. And in the meantime, we're also planning to add significant improvements to Gandalf, such as adding privacy preserving training and generative models, which is, a big request by many groups. Now, before, I quit, I just want to, mention, something that, I'm very pursuing, this, and I want to share our challenges as well as a group. We aiming to identify this year and sustainability model for a group, like, because we're researchers, but we need to support, this effort through some funding, right? So the way we are, discussing internally in a group and beyond with other, people within MLCommons is to approach it with 3 ways. Perhaps most important, it's going to be through research grants, NIH, NSF, foundations that are, very interested in specific, diseases to build, a benchmark around. And also the third one is like to explore the potential of having a business model where we can, provide benchmarking to clients like potentially pharma or payers like insurances. But this is, more down the road. But our goal this year is to explore potential, sustainability models. And I hope in the next few months, we're going to have a better understanding. We can, gather more information about all these processes. And I hope, next time we have a community meeting, I can share more information with the rest of the groups, because I think this is something of interest to many chairs.
All right. So do we have the speakers from Tiny?
Yep, I'm here. So yeah, I am Jeremy Holloman. I'm one of the co-chairs with Chava Karali of the Tiny Working Group. And as far as what we are benchmark suite targeted at ultra low power machine learning systems. So these are essentially embedded systems, mostly running on microcontrollers, occasionally like a DSP, and we have a couple of accelerators. Those processors will tend to run in the sort of tens to low hundreds of megahertz and have maybe a meg of flash and SRAM, give or take, and running on kind of in the low milliwatt range of power typically. The result of all that is that we focus on lightweight models, typically under a megaweight. Those models and the use cases that we support are things like wake word or keyword or some relatively low resolution image processing, kind of similar things like that, and some sensor based kind of accelerometry type applications are pretty popular with a lot of our submitters. And so all of those are in the field right at the point where the data is being generated. And another implication of that is that typically it's batch of one inference. So we roll that into the benchmark in order to accurately reflect the real use case. Our current benchmarks, we've got 4. We have keyword spotting, which is built on a depthwise separable convolutional model. It's about a 50 K weight or K parameter model. We have a visual wake words model or a person detection based on a V1 mobile net. It's probably the largest model in terms of computation as well as weight footprint that we run. An anomaly detection, which detects, which operates on sound, uses a fully connected model of an autoencoder. And even though it's a little heavier on the weight side, it's definitely the lightest weight model in terms of computation. So it runs in a very small number of cycles. And then an image classification built on a very small ResNet. Anyway, so those are the current benchmarks. That's what we do. And we implement all of those on an M4 microcontroller from ST as a reference platform. So you can easily buy the platform for, I want to say it's $30 or so, download the code, and in principle get running, making verifiable measurements in an afternoon, give or take. So what's been going on lately? We had our latest round submitted in November. We had 8 organizations submitting, including 3 new submitters, for a total of 17 different systems. Because some organizations submitted either multiple hardware or hardware operating at a couple of different points in terms of supply voltage and frequency and so forth. And most of those 11 included energy. We've been working really hard to get the energy measurements as widespread as possible because, as I mentioned, in those use cases that we focus on, embedded devices, typically battery operated, energy is a really important metric. And we had a good variety of hardware represented. Several different microcontroller architectures, FPGA, some custom accelerators, and several submissions had a combination of those. So maybe an ARM microcontroller with an accelerator on the side, or similar combinations. So as far as what's coming up next, we have some new benchmarks in the works. One that's we're actively being worked on. It's a streaming audio benchmark with an LSTM based denoiser. If you were paying attention in the list of current benchmarks, you might have noticed that there is no recurrent neural network in the present set of benchmarks. The devices that we're working on are generally a little bit smaller for most transformer-based models, at least as they exist right now. I wouldn't be surprised if we start seeing transformers migrate down to where we're at, in the next couple of years. But presently, we don't see too much of that in our use cases. But we do feel like we need to get a recurrent model into the suite, and so this streaming audio benchmark should accomplish that. The other things that we're hoping to get from that streaming audio benchmark is sort of a more faithful replication of the normal operating mode of our devices. So if you imagine a wake word where you want to get a new chunk of audio maybe every 10, 20 milliseconds, you rapidly process that in 100 microseconds or millisecond or something, and then you go back into a deep power down mode and stay asleep while you accumulate the next 128 or 256 samples. So that style of operation, I think, is much more realistic and representative of what's important to a lot of the customers of our submitters. And so we're hoping to exercise that with this streaming audio benchmark.
So I think data sets is next. Kurt, you got 3 to 5 minutes.
All right. Hi. You saw me just a few minutes ago. I'm going to talk a little bit. I'm the new chair for the datasets working group. Our mission is we want to build datasets. Everybody's building benchmarks. Everybody's building algorithms, and this is the other part of the recipe. And specifically, we want to try to create datasets that are really, really usable. And that means they need to have impact. They need to have real world relevance. They need to not have licensing encumbrances. And we want to, put effort into making sure that they're hosted in a practical way, which basically means, affordable access. And given egress costs and giant sizes, this is, a challenge. And then more recently, we're shifting a little bit of a focus towards creating tooling to build data sets, going one more meta level up to try and say, you know what, it's not just slogging through making data sets. It's like, let's make it cheaper and easier for folks to make data sets themselves. So Peter organized a workshop at Asilomar in early January, and it was like data sets 2030, like data set requirements for ML for the world over the next, decade or so. And there were a lot of breakout groups, and there was a lot of discussion. And so these are kind of what you see here, a lot of the problems and issues that we came up with. And, there's issues around versioning and forking and changes, yet we also want it to stay fresh. There's issues around metadata management. As data sets evolve, metadata grows in complexity and size. There's scaling. Data sets can be, terabytes, 10 terabytes, possibly petabytes eventually. How are we going to manage that? And then, of course, there's also issues around licensing and governance and building communities around that. So we decided that we would start focusing on building a new project around one of these meta projects around a data set service for focusing on the issues of collaboration, and in particular, those first 3 items, dealing with the issues around versioning and metadata management and scale. So what is this going to look like? Okay, our inspiration is Git and maybe a bit of GitHub, in the sense of, it's easy for a lot of collaborators to operate asynchronously. It's easy for you to version things. That absolutely current tooling does not scale to large data sets, even with LFS. So we want to focus on the scalability, structured metadata, fast versioning, a lot of contribution, but also the consumption, meaning it should be easy if you want to declare a new data set. Hopefully you can do it just by metadata manipulation, and then you can compactly refer to it and thus share it. And so we think that we have some ideas around that, and that we're already we're buying a development server. We've already got ideas for the architecture. There's multiple layers. And I think we're gonna hopefully have something, move pretty fast. So this is my pitch. Come help us. Come reach out to me. Come to our weekly meeting. Hang out in our Discord channels, and come help us build this. Thanks.
Awesome. Thank you so much. All right, inference. Ramesh, are you on?
Yes, I am. So hello everyone. This is Ramesh Chukka from Intel. I'm one of the co-chair for Inference Work Group. I'll give you an update on what's happening with Inference Work Group. So our purpose, right, to have a inference benchmark suite for measuring the, how fast the systems can run these models in a variety of scenarios. In terms of our goal, obviously to find the representative workloads for benchmarking, and also identify the scenarios for realistic and fair evaluation. As part of that, find the right task and determine what are the latency and accuracy targets. So that's something the work group does for any new benchmark that is going to come. And also our goal is to have more submissions from a wide range of industry participants. Providing the links here to join the Inference Work Group who are interested in it, and also the link for more information on the benchmark. All right, updates from the last quarter. Already, David mentioned that we had the version 3.0 inference submission in March, and then results published in early part of April. As David mentioned, we got a record number of submitters this time, 25 submitters, with record number of performance results, almost 24% more than what we had from last submission. And we also had around 2,400 power results. In terms of what's happening, right, in addition to that, we started two new task forces for the new benchmarks that we're going to add in the next quarter. One is for DLRM v2 and the other one is for large language model. A big shout out to the open source CK automation platform that enabled many of the inference benchmarks to be submitted in this round. So you will get more details on that from the work group next in the next slides. So what's coming in next, right? So we have our next submission for version 3.1 in August. The results will be published by end of August. Because we are having the two new benchmarks that are being introduced. So we'll be having a model freeze by end of this month, and then the code freeze will be June 2nd. As I mentioned already, we'll be having a DLRM v2 benchmark, which is enhanced from the DLRM v1 with more embedding table complexity. With that also adds with the compute complexity that is very much emulating what the industry is doing for the recommender systems. And also we are working on adding large language model benchmarks for inference. One is 175 billion model, other one is 6 billion model. In terms of the pipeline for next year, we have stable diffusion, GNN, and autonomous driving benchmarks are in the pipeline. In terms of the challenges, so as the new benchmarks coming in, we are debating on, hey, how would we, look at, is something what benchmarks need to be retired, or how do we increase the carrying capacity, determine the carrying capacity? Those are the active discussions that are happening within the work group right now. And in terms of the community asks, we would like to have more participation and then make more submissions, obviously, and also have folks take more participation in terms of getting the benchmark ownership. That's the update from me, David, back to you.
All right. One of the things I want to mention in particular is actually the inference group. So first of all, thank you for the presentation, Ramesh. The inference group is actually, we are actively recruiting a working group chair. If you would like to take over for Ramesh, I think we would love to get some more folks involved. Right, Ramesh? Thumbs up.
Yes, yeah, right.
We're not deposing Ramesh here, but we're actually, I think Ramesh is going to be probably stepping down at the end of the second quarter. So we'd love to get someone to help take over and help lead on the MLPerf inference side. So that's a great opportunity to get involved and work with the community, especially if you are from a submitting organization. That would be greatly appreciated. All right, so next we are going to go to Grigory. And Grigory, just a reminder, 5 minutes only. We will have to cut you off. I know in your slides there was a lot of text, so if it all gets read, we'll be here for quite a while. So hit the high points and take it away.
Yeah, cool. So I will try to go quickly, and I have been participating in probably all MLPerf inference submissions and talked to many companies. And what we realized that while inference is really fantastic effort and it works well, still companies kind of have a pain preparing submissions, running them across different hardware, particularly if they want to compare them, reproduce results. And that's why last year, at the end of last year, we decided to create this task force to try to create actually something what was missing, a platform, very simple open source platform where you can actually automate the process of running benchmarks across whatever implementation you want to have from NVIDIA, from Intel, from Qualcomm. And the idea was that you could actually start comparing results before you submit them, optimize them, and then you get the best results. So the cool thing that the framework is out, so you can actually check it out. It's still, there are lots of work to be done, but the preliminary result that you can actually now start visualizing all the past submissions. So actually see how we moved from version 2.0 to 3.1, this kind of Pareto frontier, which changes really cool. And at the same time, you can now already start adding your derived metric, any metric like performance per watt or performance per dollar on using this platform. And again, it's an on-prem platform, so you can use it actually in-house if you want to run your benchmarks. Now, what is really cool, so with this framework, we also decided to test it with the community. So the idea was to try to get more submitters. And what we did is we opened the whole suite to the community. And we had, first of all, huge thanks to Neural Magic for actually working with us to validate this framework, and they submitted really great results with that. But also we had some students who actually used the framework without our help, and they also submitted lots of results through the CTuning Foundation, which I'm representing. And I will not go through all the details, but you can actually check that we now cover most of the implementations, and we can run the MLPerf inference with any software and hardware out there. So I will not go through that much because you saw probably all the publicity and so on. What is interesting is next, what we're trying to do next. So what we're trying to do next is, once again, there are two big things we're trying to do. We want to get much more submitters, and so the companies don't necessarily have much time to optimize their benchmarks across like variety of hardware or kind of reproduce their previous submissions. So we're trying to connect MLPerf inference with students, with researchers, just like what we did with a few students in the last round. So we're preparing, and it was based actually on many feedback which we got from companies. We're preparing the first open tournament, which we'll be trying to do with this platform for the Inference v3.1 submission. So please, if you're interested, get in touch with me and Arjun Suresh, who is working with me as another co-chair of this task force, while preparing it for within the next month. So, and the idea is also to get all your software, hardware to be supported in this platform. Again, it's for free, it's a free effort, so just please get in touch, and we'll be very happy to provide this support. And what is even more interesting, this is the last thing, just to announce that at the same time, there was another missing thing in inference, that, okay, we have those lots of great results in MLPerf inference, but how we can like build applications based on them. So we're trying to provide a way to automatically, when you pick like any point on this graph, which you can see online now, that you can actually generate a working solution, whatever it's it's image classification, object detection, it's NLP, which will be with a module Docker container, which will be produced to you, and you can actually run it, reproduce it, and check the metrics that they're correct. And I think this will be the part which we'll do in hopefully within the next few months. I think it will kind of connect MLPerf inference with end users. That's our goal. Please, once again, If you're interested, we have weekly meetings and you can join us on Discord. I hope I'm fine within 5 minutes. Thank you, everyone. And yeah, hopefully we'll chat later. Whew, wow.
Perfect, Grigori. Thank you very much. All right, we have training. Oh, Eric. All right, so we have a live Eric Hahn.
Yes.
Take us away.
Hi, I'm Eric. I'm one of the co-chairs of training along with Ritika. I think we talked about this earlier, but John has stepped down, so have some fresh people. So yeah, training, our purpose is to do MLPerf training. Not gonna talk about that too much. We benchmark training performance across a wide variety of workloads. The updates from this, I guess like the last 6 months or so, we have the reference benchmark code for large language model and which is GPT-3, and DLRM, which is DLRM v2, which is based on the DCN v2 Deep Cross Network version 2 architecture. So those two are complete, and they're going to go into the next training round for 3.0. The training 3.0 survey is out for registration, and the submission is in roughly, yeah, it's May 19th, so in roughly a month. And so please register for that and sign up, and watch our emails. Also, if you're submitting for the 2 new benchmarks, please let me know if you have any questions, because I think we've done a really great job, but there's always these last minute kinks to work out. David Geraldo has done a really great job with MLCube integration and for 2 benchmarks, BERT and Reddit. So we're working on making the benchmarks easier to run and make sure that all of those kinks are worked out. So also, yeah, let us know if there are any issues with that. But we're basically working through each benchmark roughly like one per month to kind of make sure that there are no issues with running the benchmark, like hardware is, there are no like hardware issues, that kind of thing. We have a bunch of new benchmarks that we're working on. So we have 4 task forces in flight right now. So there's stable diffusion, GNN for graph neural networks, we have automotive, and we have power. So training is pretty active and lots of people are doing a lot of different things. So yeah, training 3.0 submission deadlines and publication is here. For 3.1, we're going to be landing stable diffusion and power. So that's in roughly 6 months from now. And we need to finalize the benchmark roadmap for 2024 because there's GNN and automotive, which are candidates. We'll see which ones make it, just depending on how the execution goes for them, since it's a little far out and a lot of these things are still in the scoping stage and like initial work is being done. We will probably need to drop some old benchmarks to make space, because these are essentially like 3 to 4 new benchmarks that are going in. And I think there's a discussion between mainly ResNet, 3D-UNet, and RNNC, yes. So if you want to be in those discussions for which one that we drop, please come by training, and you can join training at this link. Any questions?
No questions.
No questions. Okay.
We did. There are no questions in MLPerf. No, seriously, if you do have questions, please follow up offline or in person. All right, HPC. Oh, and Steve is going to be giving the talk.
Yeah, I'm Steve. I'm actually the outgoing chair, but still doing at least one more update for you guys. So the continuing chair is Imani from Argonne. I'm actually at Lawrence Berkeley National Lab at the supercomputing facility there. And then Andreas, who you met earlier, is the incoming chair. Thank you very much, Andreas, for stepping up and taking on the role. I'm going to stay involved for the foreseeable future. Little details there to join the group if you want and when our meetings are. So the HPC group, HPC is, of course, high performance computing. Of course, we're all doing high performance computing, but here we just mean in the traditional sense, these kinds of supercomputer systems, like those that appear in the top 500 list, which is a ranking based on high performance LINPACK. So a lot of these systems are supporting scientific workloads. A lot of them are at national labs, that kind of thing, but there are systems at industry sites as well. So we're doing ML performance benchmarking on those kind of things. So we're very much complementary to MLPerf training, and a lot of what we do is derived from MLPerf training. But we're complementing that with workloads, scientific machine learning workloads that are relevant for these kinds of systems. yeah, we measure the time to train a model just like MLPerf training, but we also have a throughput measurement where we can fill a system of any size with many models training concurrently, and you report models per minute. We also participate a bit in outreach things like birds of a feather sessions, trying to put together some tutorial submissions and things like that. So some specific goals, I interpreted this as kind of things that we're focusing on these days. The intersection of HPC and science and machine learning is still relatively immature and rapidly evolving. So a challenge for us is kind of how do we kind of stay relevant and stay fresh? There's really no ResNet for that kind of space, at least until we, successfully accomplish that. So we are working these days on trying to add more benchmarks that kind of fill out the space more, add more metrics that might be relevant to HPC and science. One of those is power that we're very much trying to incorporate. One of our current goals is to try and increase interest in participation. I'll come back to that in a moment. So updates over the last quarter. We are working towards our next submission round, version 3.0. Although this is actually aligned with version 3.0 of MLPerf training, and that'll be in October. We like to announce results at supercomputing because it's sort of the main conference for our community. So we're working towards that. Well, some of the things we've been doing, one of the big things we've been doing a lot in our working group meetings is looking at our rules. Andreas actually led an effort to do a lot of discussion within NVIDIA, but also talking to a lot of HPC customers to collect feedback and think about ways that we could increase the popularity and participation of MLPerf HPC. And so that led to a series of proposals, which we spent a bit of time discussing and talking through. We had a task force for that. Here's just 3 of them. There were actually like 6, I think, right? But some of the ones that we were considering most seriously. So one thing we've been doing different from MLPerf training lately is, or at least since the beginning, is the way we handle data movement. So in MLPerf training, you can have the data already kind of staged on the nodes when you start the performance measurement. So previously we had required that any data staging, like from a parallel file system onto nodes, has to be included, sort of get more of a holistic picture. But there was a bit of feedback that they got on how it's better to kind of keep things decoupled. So actually now we've accepted this proposal here to exclude the data movement from the timing, so that these are still decoupled. We're still trying to find ways to make sure we're capturing that data movement part, maybe with optional logging or working with MLPerf storage. The second proposal was not to actually do that full throughput measurement, but actually just allow to estimate it by measuring time to train a single model and then kind of just scaling that out to what you could fit on a system. And then some terminology, other things that are just meant to clarify results. So yeah, the outcomes of this, basically, we've decided to accept A and C here and reject B, and these can be reevaluated later. A big thing we're doing is we're adding a new benchmark, and it's a pretty exciting one. So it's based on AlphaFold 2. So this is a protein folding benchmark, pretty relevant for high performance computing. We're basing it on the OpenFold implementation, and this is coming along pretty nicely. Folks at NVIDIA are doing a lot of work on that. We're updating one of our reference implementations for the CosmoFlow benchmark, and we're working a lot with the Power task force. Up next, we're focusing a lot on outreach. We have a Birds of a Feather session at ISC, which is the European equivalent of the supercomputing conference. Well, we want to put together a tutorial. We want to kind of have some more educational materials to try and draw people in and help them with a participation in the upcoming submission round. I already said we're working a lot with Power, the OpenFold benchmark. We're going to try to finalize that. And then just the schedule for this year, version 3.0, we have the freeze in June and the deadline is October 6th. And that's aligned with MLPerf training. That's all. Thanks.
Awesome. Fantastic. Thank you so much. And I actually want to say just one quick note. One of the things that I'm most excited about this year is actually getting power measurement for MLPerf training and HPC. I think we all saw there's been a lot of discussion about what is the environmental impact of training. And, a lot of that is sort of based on managerial back of the envelope math, which is in many cases not true. Something that Dave Patterson has pointed out. And so one of the things that I really hope we can contribute to the community is getting a firm grasp on what are we actually burning in terms of energy and power to train models to inject some, real measurements into the discussion. So, all right, Curtis is up next with the storage working group. So take it away, 3 to 5 minutes.
Okay, cool. So hi, I'm Curtis, one of the co-chairs John and George is another co-chair, and our hero is Juana, newly crowned hero. So storage is not AI, but you need storage to make AI work. So what do we do? You can read the details here, but the goal is to link your MLPerf performance with the output of our benchmark, so you can get a coordinated idea of, I've got this farm of accelerators. Well, how much storage do I need to keep that thing busy, to not have the storage be the bottleneck or not be too big? We want to do that without any hardware. So, and without any AI training, because, storage people, we don't know squat about AI. So we need to decouple those two. What we're doing in the benchmark is we're simulating load from various different neural network types, UNet 3D, DLRM, and natural language processing. But we're doing it for both PyTorch and TensorFlow, because we don't know what the practitioner is actually going to run. So we're going to try and provide all of the different data points. And PyTorch and TensorFlow apply very different workloads to the storage, so it's relevant. So the customer can compare storage products, but also the storage vendors can optimize for the workload. They can reproduce it and say, okay, this is what I need to do to increase my performance for the AI community. Because this is our first release, we were only created about a year and a half ago. So we've released in February the first beta of our benchmark. We've just now released the second beta benchmark. We expect to release the GA, basically open our submission window in about 3, maybe 4 weeks. We've got a list of vendors who are so far indicating they likely will participate, so that's great. We're looking for more. Short-term next steps. For the majority of the people are storage people in the working group. There are some AI practitioners as well, but just learn about the processes that MLCommons uses and make sure that we're fitting into that and providing an easy to use benchmark for people to run. In the sense that there's crawl, walk, run. We have started with a single node benchmark, so we don't do distributed training yet. We get that stable and validated. We have validated that the tools we're using are working correctly, but that we get that worked out, and then the next step is going to go to multi-node training. Yeah, and one of the things it's difficult for us to deal with is that the big O of solutions is a big O of practitioners. There's commonality is something that's difficult to come by in the AI environments. So issues and asks, a paper published by Meta about a year and a half ago, 50% of the watts that they consume, the electrical watts, are consumed in data prep, not in training. And so we believe that that's part of our remit, if you will, for the working group. But we need help designing an analytical framework that will include data preparation. That's an example of big O equals big O, right? That it's very application specific. The storage workload applied from that is unique and different from the ML workload. So we're asking for help with that. And that is that. I'm quick.
Fantastic. All right. And next up, we have Xin Yuan from the Benchmark Infrastructure Working Group.
Okay, hello everyone. I'm Xin Yuan, and I'm co-chair of Benchmark Infra Group, along with Kong Tao, who is also sitting around there. And the purpose of the group is to develop an infrastructure and the toolings to help our different working groups to submit their benchmarks, and to make sure that the benchmark submissions are compliant with the MLPerf rules. And one of the main focus of the group currently is to build this submission service, where it's basically a website that MLPerf submitters can go there and submit their results, and we will automate a certain amount of compliance checking process to make sure that your submission is correct, compliant with the rules, and it will automatically generate results for the submitters. So we have currently been able to support training, inference, and HPC submissions, and we're also working with the different other working groups to help with their needs. And another focus of the group is to maintain the compliance tools, such like login libraries, compliance checker, results summarizer. Those are mainly for the training related benchmarks right now. And some of the updates in the last quarter is
we have been working on automate and improve the scalability of our submission service. For those of you who have been here who have been using the training and inference benchmark for some time, you know that we have evolved our submission process from a fully manual GitHub-based submission to a script running on the web server. And now we are further going to leverage cloud services. Well, we migrated our service to the GCP's App Engine so that we can provide a better scalability and availability of our service. And the last inference 3.0 submission is the first submission that was fully run on our new submission infrastructure. We are also continually working with training group to support the next training 3.0 submission that is going to happen in a month. What's next? We are building an auth system for our submission service that is going to provide a better security and a better submitter experience. The auth system is going to make sure that your submission is secured, and it makes sure that the party who submit the results are the ones who are pre-registered, and they have make sure that you have signed a proper agreement with MLCommons. All kinds of things will be fully automated. And we are also working on a few other DevOps improvements that is more of the internal tools for deployment and management of our submission infrastructure. And we're also working on helping with other parts of the submission process, such like a review process. We are working on some code scripts or tools to help the review committee to better do their review process. And finally, we have a few improvements in documentations and releasing process that are being worked on. So that's pretty much the updates. And a few asks from our group is one, we would like to work with more working groups to help with your submission needs. So if you are building a new benchmark, or if you have a need to automate the compliance checking of your benchmark submissions, please do talk to us, and we would love to help and understand your needs. And also, we would like to have more contributors to our group. Especially, I think this is for people who are new to the MLCommons benchmarks. This group could be a great opportunity for you to start your contributions. So we would love to welcome more contributors to the benchmark infra. And that's it. Thank you very much.
All right. Thank you very much, Shin and Kung Tao, for all of your work. It's part of what helps the benchmarks run smoothly. So, all right. So the SUP, we have the science working group. This is going to be remote. Do we have our remote speaker here?
Yes, we do.
Jeffrey, you are here. Fantastic.
So the first slide pointed out that we have a change in working group chair, which I think David already announced when he went through the new election jury, has replaced Tony Hay as one of the co-chairs. So the science working group is basically looking at AI for science and engineering, covering a range of domains, and we're both looking at particular algorithms for particular domains, also at algorithms such as those for time series, which will run across many domains. Actually, another area which is very common both in industry and science are images. There's lots of data taken in science, which is image-based, so there are several image-based benchmarks. And I mean, our main goal is in supporting scientific discovery, so that's actually our primary metric, not performance, not compute performance. So we want to go a range of scientific domains. We have an interest in using good principles such as fair metadata to ensure our results are easy to find and reproduce. And we also, as well as the research use, we have a strong interest in education, because we found our early releases had a lot of interest from used by students and student projects. So here we have what we've done over the last quarter. Well, we've had these 4 benchmarks for some time. They're now fully available and usable. We were mainly focusing on how to present them. And in the MLCommons notation, we only have an open division, and we have no closed division. And so you're allowed to, in particular, as we're aiming to improve the scientific discovery, you're encouraged to change the benchmark. And another feature is we have rolling submissions, not fixed submission dates. As our submissions are well, we already have a couple of updates. They're likely to be of different types. They're not easy to summarize in a table. So we in suggesting a blog-like interface so that every submission is attached to a description. We have been, in the recent meetings, we have looked at new benchmarks. An area which we've got several new benchmarks is the so-called area of surrogates. These are AI models that learn to reproduce the results of large-scale simulations. And we have a couple already identified. One is one I was working on called on virtual tissues, a digital twin for organs. And another one is from Oak Ridge and the DoD PET program on computational fluid dynamics. That's an inference benchmark where you're trying to predict the turbulence from the AI model. We also, through Vijay and his collaborators, we have a lot of interest in particle physics benchmarks, which are called FastML. And that's also was discussed at a recent big NSF PI meeting. Another update for this last quarter, our paper, which we presented at the 2022 ISC meeting, has been published. And we have 3 white papers whose names will be on the next page. And this table here gives you the benchmarks, the area, and the nature of the problem, and the nature of the AI model, and also who produced them. RAL is the Rutherford Appleton Laboratory. Okay, this is the last slide. Well, we want to complete this slightly different submission interface with where the focus is not on the table, but a description of what they did. We want to continue the new benchmarks, and we have these 3 white papers. One is on effectively the FAIR issues, to what are the right ontologies and metadata. Another is actually a sort of paper on how to make advanced science using machine learning efficiency. And the final paper really came out from our discussion of education. So we decided to call it benchmark carpentry, to rhyme with software carpentry, to see how best to do the benchmarking for our students. And these papers are all open Google Docs, which you're welcome to join. Thank you.
All right, thank you very much. And what do we have next? Research. Are there slides? Oh, there are slides. There were no slides this morning.
Just in time sliding. All right, so I'm BJ. I'm a faculty member at Harvard, and I had the pleasure of working with the MLCommons crew for a long time. And one of the areas that I'm especially passionate about is preserving the research sort of a culture within MLCommons, because originally much of what's where things started did come in part collaborating with researchers from academia, and so that's sort of in our blood. And so I'm always cribbing about how do we keep research as a big thread that's kind of alive, which I do think, especially as Peter mentioned right at the beginning, for this space, it's especially important to be one-on-one in touch with what's happening in the research field. And so generally research, the way we kind of organize it is like, there are a bunch of different working groups that are fundamentally under research. You can think of it as like, the 3 real tiers. There's like the free tier, there's the development tier, and there's a product sort of a tier within MLCommons. You can think of it that way. And research is where things are, usually get incubated and people are welcome to bring their ideas. So typically, what we have is sort of like, this laundry list of these amazing groups. If you actually look at it, it's about almost, last time I counted, it was about 116 or 125 PhD researchers that are all under MLCommons research. Not that we're paying them, but the point is, that is a massive amount of talent that's sitting in these research meetings. If you try and work that out in the numbers, it's pretty staggering how much money is actually being spent in MLCommons as PhD researchers. So big shout out to all those folks who are doing incredible work. But we do have sort of a big vision about where we want to take MLCommons research to kind of grow. We want to really see it sort of bake into a big nexus where we bring industry and national labs, the government agencies, and academia all together. We're taking incremental steps to get to this big vision where we're really driving this MLCommons, much the way we bring people. How do we bring research communities together, specifically academics? We want to bring the student, the next generation of all of you are here because you've been trained well. And in other ways, my job and many other people's job is to kind of give you that next generation of talent that's coming through. So we want to build those pipes, and that's what, we've got a whole pipeline we're kind of setting up in process. This is a multi-year sort of a vision, not something that we can just do today or tomorrow. But we're making good headway in this. Just as a quick laundry list of all the things that the research group kind of cohesively does, or like we obviously started some of the benchmarks all, in the research. So a lot of the new things like medical and so forth that Alex was talking about were incubated in the research side, and they're starting to mature out now. So a lot of new ideas kind of start off there. Obviously, disseminating knowledge. We write papers that are in flagship conferences. We're not just doing engineering work. Otherwise, they would not be showing up in some of the, world's best conferences, right? So we're actually, we have a role in disseminating that knowledge out. Then we do a lot of workshops. I want to give a big shout out to Tom St. John, who does all our workshop stuff. He's had a consistent record of doing MLCommons workshops at, MLCIS and many other architecture venues. And so that's been a consistent thing. Again, it's a way of engaging the scientific community. We run tutorials. In other words, how do we use our tools is sort of a critical thing. We've even gotten into the business. Xijang from Zurich has been leading this vision about we should have a journal that's just dedicated around data sets and data-centric AI, which, Peter was talking about. Data sets are critical to us. Now we're getting into engaging them, undergraduate community, very excited last year to help kind of kick off, SC typically does competitions, supercomputing does competitions, and they actually used MLPerf benchmarks to help undergraduates understand how to, build these kinds of systems. So very exciting stuff in there in terms of inspiring people. We're starting to get into the role of giving awards. I'll talk a little bit about the Rising Stars program, which is something very exciting for 2023. We're in the process of thinking about how can we build pipelines with many of you folks who are in the industry. So you get, you create internships, but we want to build that bridge between internships, between what you do and how MLCommons can facilitate, students from Rising Stars program. And in the process of rising, trying to raise external funding to be independent of member organizations. Primary goals for 2023 are really kind of, helping existing research groups succeed. Research is not a working group that specifically does one thing. It's more that we're there to support other groups that are really doing activities. And I'll talk a little bit about the exciting Rising Stars program that we've put together. And then obviously the goal is to kind of launch some new research threads, some of which I've already kind of come up with new folks in the room today. So I'm excited about that. So one big thing is, this notion of Rising Stars, where the Rising Stars is, ML students are incredible, but there's really no sort of a neutral award that says, hey, these are some amazing, 30 or 40 candidates from, this year's cohort that are just outstanding and doing incredible things. So what we wanted to do was to kind of, have MLCommons being a neutral entity, recognize some of these students. Now, we are simply facilitating this and talk about the organizers who are doing the awesome work. But the goal is to have students apply into this program, and then they'll be able to put on their CV that they were one of the people who were selected. The names will be announced at a conference and so forth. And through that, we can, then build out pipelines for internships and so forth. Long story short, the goal is to kind of support career development, provide them with support in terms of moving through this complex ecosystem, and hopefully, identify how to have better job skills and so forth. And what we're really trying to do is to connect researchers, both in academia and industry, together with each other, so we can kind of build the next generation of pipeline. Now, this is really the brainchild, and not to MLCommons, it's actually the brainchild of Udit Gupta, Abdul Rahman, and Lillian Prescott, who are actually young faculty. Abdul Rahman is a postdoc at Harvard, but they were the ones who actually created this thing about this Rising Stars vision, and then they were looking for support. And then MLCommons, being on MLCommons side, I was like, oh, this is a great opportunity for us to help them sort of, kind of raise this thing into some mature program. So we're now got funding support that we're giving them to help them sort of execute the program, which is really exciting. The next slide was basically talking about where things are going, which is effectively, we've got support to, thanks to MLCommons, we've got support to kind of, select these students, bring them out. But we're looking for a venue where we can host it. Peter kindly is kind of looking into Google. Sujata just today, right after, when she mentioned the Rising Stars program, said, oh, I'm happy to look into it at VMware. So we're just looking for a place in mid-July. If you folks are able to do that, it's awesome. You get first dibs on some of the best rising talent and ML people. That's not cheap, I'm telling you. So that's a good opportunity for you folks. So let me know if you can help. Yeah, thank you.
All right. Thank you, VJ.
Okay. The objective is to enable measuring energy consumed of submissions across all of the benchmark categories. And we measure both system power as well as energy consumed. And we kind of choose the metric of what we measure based on what is the metric of performance. So if it's throughput oriented metric in terms of performance, we measure power. And if it's more latency sensitive, that is the metric of performance, then we look at the overall energy that is being consumed. And currently, we have enabled the power submissions for the inference stream, as well as TinyML have enabled the power methodology for the M streams as well. In the inference, we cover both the data center as well as the edge categories. And our key kind of intercept, I would say, for this year is going to be how can we enable measurement of power for the HPC and training verticals. Over the last year or close to 2 years, we have established a good proof of concept and as well as adopted a lot of new submitters and submissions for the inference side. And the next step function to kind of evolve the MLPerf power methodology is to embrace a lot of the verticals that are there within the the MLCommons community. And HPC and training are the biggest intercepts from that perspective. I'll go over a little bit on what more we have been doing on the HPC and training front in the slides coming up. But this is just a preview of that's going to be one of our key targets for 2023. And having a quick look at the recent round of power submissions that have happened, right? We have had 2,800 plus submissions across a whole bunch of different unique systems, in the version 3.0 submissions. And as you can see from the graph on the right, over different MLPerf inference versions, we have gradually grown the amount of submitters as well as submissions that are there. We had a whole bunch of new submitters this time, so kudos to all the folks who have submitted for the first time. That includes SEMA, New Chips, Dell, Fujitsu. There's a whole bunch of different organizations for me to name everybody. But overall, the kind of the methodology that we had established for power measurements has seen us embrace over 7,000 power submissions in around the 2 years of time frame that this has been live with. This is definitely a good trajectory, but we kind of want to get to more adoption in our submissions. Specifically, if we look at a metric which is what is the total number of submissions for inference and what percentage of the total number of submissions are for power, that percentage is a little less than 50% as it stands today. So what we would like to do is to encourage a lot of the submitters to start taking a power aspect to their submissions as well. It is not really super hard to get power measurements for your performance submissions. We are using a lot of the existing framework that is there for the performance side. It is just adding another API layer to help with the power measurements as well. So it's kind of a rallying call for all of the submitters, who are already doing submissions for MLPerf performance to also be cognizant and think about how they can start doing power submissions as well. Recently, we had a whole bunch of news and media outlets covering that the energy efficiency that are that has been established is from the MLCommons community is kind of a good kind of indicator of how efficient and how good the systems are. So it kind of helps us move the needle in terms of being more energy conscious for all our system submissions. Okay. So I kind of wanted to delve a little bit deeper on what are we doing so far for the HPC and training side. We meet weekly. Currently, it's at Wednesday Pacific time, 8:30 a.m. And it's open to all members of the MLCommons community. What we are trying to do there is essentially come up with a methodology on how can we scale and have adaptability of power measurements for both HPC as well as for training. We try to brainstorm on a whole bunch of different ideas on how we can do it. Obviously, this is not a unique problem that we are solving for the first time, right? A lot of the folks who are there in this call would be familiar with the Green 500 methodology. And that is an kind of, every year we see the latest top 500 and the Green 500 numbers come up, in the third quarter and fourth quarter of the year. So one thought process was, hey, can we see if we can leverage some of the Green 500 methodology and try not to reinvent the wheel and use some of the salient features that they have in their architecture and adapt it to our needs. And the other one was to kind of, be a little bit more revolutionary in the sense that let's try to see MLPerf, HPC, and training are very unique segments in themselves. So let's see if we can cater a methodology which can be adapted across the industry, which is more catered to the HPC and training submissions. So these are kind of the flavors of discussions that are currently happening in our weekly meetings. The status that we have as of today is, when we are talking about system as a whole, there is a non-trivial amount of computational capability of the system that can be measured, but there are also certain very important functionalities that are currently, which we may have to be estimated, right? And the group is currently brainstorming and figuring out what percentage of the system can be measured and what percentage of the system is going to be estimated. So to that extent, the node measurements are some things we have kind of agreed on what the best methodology is currently that we can adapt. And the interconnection, that the switches and the interconnection is currently the hottest topic of discussion, where there is a very good possibility that we may have to rely on estimates for how we can estimate the interconnect power. But exactly how we can come up with that estimation and how can we ensure that all submitters across the spectrum of submissions, are not disadvantaged by whatever methodology we choose. That's the current discussion that's ongoing. And there are things which we have not yet fully aligned on with respect to cooling and storage estimation, and that's something which we continue to evolve. The internal targets that we are having within our work stream is, say, by end of June, that we come up with a estimate of what's the methodology going to be for HPC and training. And after that, we kind of have a proof of concepts and iterate over how can we refine this and how can we truly make it scalable and adaptable. So if there are submitters and folks who are interested in doing HPC and training submissions, and they are also wanting to have a power perspective of it, please kind of reach out, write to power@mlcommons.org and reach out, and we'll be more than happy to kind of have this inclusive submissions for HPC and training. All right, and it's coming towards the end of the presentation. We just want to kind of make sure that all the attendees who are join the Power alias. That's the easiest way to kind of get access to all the documents that we are sharing and writing and the minutes that we are capturing in our meetings. And we want more and more participation. Recently, one example I can give is we have been having MLPerf power measurements, for quite a few rounds, but it was until the version 3.0 is where we had some submitters who kind of found out a blind spot that is there in our methodology from inference submissions. And it is very likely that this blind spot was always there in all our submissions, but we never really unearthed that unknown, essentially because we didn't have that level of system that was being submitted on. Now that we have increased the range of the system submissions from basically watts to kilowatts, essentially that's the plethora of options that we have in our inference submissions. We have unearthed that there are certain categories of systems for which we need to kind of revisit our methodology. And that's something that we are currently focusing on to kind of correct that. And the reason I mentioned that point and why that is of relevance over here is unless we have this gamut of different types of systems which are being submitted for power, we would not know if there are any unknowns in our methodology. We try to test out everything that we can, but there's only so many knobs that we can tune and we can figure out. So more participation from a lot of the submitters will help us make our methodology more efficient and robust and scalable across the breadth of all the systems that are being architected in the space. The MLPerf Power Working Group meets weekly on Tuesdays at 3 p.m. And we're kind of very flexible with when we meet for this. We have participants from Southeast Asia, just from the Asian subcontinent, from Europe, as well as from the US. And we also try to have different time zones where we try to accommodate different participants as well. So there are mainly two, to kind of reiterate, there are two big work streams which are currently happening within the power streams. One is the inference stream, which meets on Tuesdays at 3 p.m. And then there is a dedicated task force, so to speak, where we meet for the HPC and training, and that's on Wednesdays at 8:30 a.m. So if you have any questions or if you have any comments, I'm happy to take them here. Or if you want to write them and if you want to join our meetings, please feel free to reach out.
All right. So thank you very much for that, Tejas. I guess I can add a couple of comments maybe to echo things that Sachin said. So one is, when it comes to power measurement, as Tejas has said, we sort of have the equation mostly solved for inference. There's some bugs that we ran into at the low end of the power consumption spectrum. So for very low power devices, we did run into some methodological issues in the last round. I think there is a huge amount of importance in measuring for the large scale training and even small scale training, right? Like, something as small as, 4.8 accelerators or even, just a CPU based server. Those are all, perfectly valid training platforms. And, I think the one thing that Sachin and Tejas would really appreciate is, getting folks who are willing to step up and actually do some of the power measurements ahead of time for the next training round. The next training round is in Q4. The submission deadline is going to be sometime in October. And so, we'd like to get dry runs done for power measurement ahead of time, just so we can work all of the kinks out and, get it to be as accurate as possible. The other thing I just want to add as context here is something Tejas alluded to is there is a methodology called the Green 500, which is commonly used in HPC for measuring power consumption for sort of large scale clusters. And so that's actually a solved problem, which was great because we could sort of piggyback on some of that. What we're doing here that is especially novel and challenging is that in general, when it comes to production data centers, you cannot go in and start monkeying with the equipment and attach external devices. So, our power methodology that we pioneered in inference largely relied on taking a power meter, plugging your system into the power meter, and then physically measuring what it draws. Now, I don't know if any of you have ever attempted to walk into a production, Google or Facebook or JP Morgan data center with a random device and tried to plug it in. But I have a sneaking suspicion that, you will end up with a very interesting experience with the American healthcare system afterwards. Right. And so seriously, this is the challenge, which is that, on one hand, we have these very accurate, measurements that we can get, plus or minus a couple percent when using physical measurement devices. But in an in-production data center, we can't use those measurement devices. Now, some cloud data centers, in fact, many of them have the ability to measure power at a rack level, at a server level, at a row level, but they all do it in very different ways. And so actually getting to measure power in a live cloud data center, that's something no one has really ever done in a way that is compatible across different data centers. So if you want to actually say something interesting in a way that's sort of reproducible, that's fair, that actually allows people to say, hey, I can train GPT-3 using this much energy. Right. If you want to make that statement in a way that is comparable across different geos, across different clouds, between the cloud and on-prem, between whatever it is, you can't do that today. And so this work will actually allow us to do that, or at least get close to it. Right. As Tejas says, we may have to estimate some things. It won't be perfect, but it'll be a really big step forward for the state of the art. Dave Patterson, who is one of the people who many people have heard of here, he did minor trifling technical contributions like risk architectures and RAID, gave a talk not too long ago where one of the points he was making is that, yes, on the surface, if you do very simple math, training models sounds very demanding and environmentally costly. But if you actually have access to Google's numbers on their data centers, and if you look at what it actually takes in terms of carbon footprint, it's actually not that bad because you're using data centers that have specialized system level architectures, specialized ASICs, and are often picked out and placed where you can get low carbon energy, right? And once you take all of that into account, the story actually turns out to be quite different. And so getting the industry tools where we can talk about that at a more global level, right? Dave's data was all internal Google, probably a little hard to pick at and inspect, but giving us all the ability to talk about that in a way that is verifiable by third parties is tremendously valuable. Anyways, so if you're interested in this, please reach out to Sachin and Tejas. And again, thank you guys for your hard work and the work of everyone in the Power Working Group on this, and training in HPC as well. This is an effort across many working groups. Yeah, I used to be chair of the Power Working Group, so it's a little close to my heart. All right, so Tejas, thank you so much. So next we are going to switch over to Nusha, who is going to come and talk to us about DataPerf.
All right. Yes. Hey, everyone. My name is Nusha. I'm a research scientist at FAIR, Meta, AI, and I'm a co-chair of DataPerf Working Group along with Praveen Patriyosh. He's not here today. And I'm excited to tell you a little bit more about what DataPerf is, what we have accomplished over the past quarter, and where we are going. So DataPerf is basically is a leaderboard for data and data-centric AI challenges. Our goal is to be able to keep track of the progress in the data-centric AI community by creating these leaderboards. But we are also striving to be more than that. We want to be not only a leaderboard for data-centric challenges, but we want to also create a community and a platform to enable people to come and build their own data-centric AI challenges. If you think about it, what Kaggle did to the ML community by creating a space for researchers to go and create machine learning competitions, and through those competitions, AI community has been made very huge leaps. We think that we want to do the similar things for the data community, and that's what DataPerf is going to be, and it's right now is. Okay, and then we have also a long-term goal of establishing DataPerf as an independent entity to provide a badge of quality for data sets. All right, so what was the motivation or the story behind DataPerf? So if you think about it, over the past decade, the machine learning community has enjoyed a very tremendous growth, mostly due to the growth in the underlying hardware and also the growth in the volume of data. But recently, we are seeing that machine learning research or basically the progress in the machine learning community is starting to get into this saturation point or staggering. And that's mainly due to problem we refer to as data bottleneck. And so what is a data bottleneck? So if you think about it, the machine learning models, the source of the data usually for training machine learning models comes from publicly available or open source data sets that are everywhere. And for example, in the context of larger scale language models, people scrape over internet, they collect Wikipedia, Reddit, GitHub to be able to just put together a data set that is worthy of fitting into such large scale models that are in the orders of billions or trillions of parameters. But usually these data sets are suffering from a problem that people are referring to as data quality issues, like fairness, bias issues, poor data distribution, also truthfulness. There are lots of fake data when you just scrape over the internet. So when the data set is so large, what happens is that if your data quality is so low, you have to scrape through a lot of data to be able to compensate for the low quality. And if you can't find a way to reduce down your data volume by finding and picking the good data points, you can actually reduce down your data set. And so as a result, you can reduce from your model size and you can save a lot of compute resources and energy. That's why like a hardware community should start caring about data quality as well. Okay, so what's the solution or what's the approach to get there? It's the idea has been floating around for the past couple years. It's been pioneered by Andrew Ng, talking about data-centric AI paradigm shift. Currently, we are all operating in the ML-centric paradigm, meaning that we are like taking the data for granted and making the development as if the data is already there. But we want to move to this data-centric paradigm or world where the data is developing along with the model itself. And that's where the DataPerf comes into picture. We are striving to be that community that helps you to not only build your data-centric challenges, but also measure the quality of data set as it progresses. Oh, I just want to mention, it's an interesting statistic someone throughout a recent paper was showing that with the rate at which we are consuming data for larger scale language model, we are probably going to run out of high quality data set for training language model by 2026. And this was like public data. The way this analysis was done, they were like looking at the rate at which high quality data set is being created in the community and the rate at which we are consuming. And they were figuring out that 2026, we're going to surpass that point. And so, yeah, that's like very important to start finding solutions to improve data quality without incurring such high data volume costs. All right, so big news. We announced our first iteration of our data-centric challenges. We refer to it as DataPerf version 0.5. It's basically a set of 5 challenges across 4 data-centric domains, challenges, and 4 different domains. And if you think about it, the intersection of these tasks, data-centric tasks and domains, there's like a lot of grid cells here, but we could manage only fill up 5 of these cells. So we definitely need help from the community and people who are interested in data-centric AI research to fill up the rest of this graph. Okay, so just for the context, like what is like, let me explain like one of these data-centric challenges, for example, data cleaning. So if you think about it, there's a lot of data set out there and not all of them have high quality labels, and labeling is a very costly process. So you don't really want to go and spend money to relabel all your data set. But you want to figure out or have an algorithm that can understand or identify which fraction of these data points are more likely to be wrong or mislabeled. And so that's referred to as data cleaning algorithm. That's one of the challenges we have launched.
And the point of the challenge, the impact that data cleaning can have on that task, right? And so
Exactly.
what's the potential accuracy boost?
Exactly. That's one of the other things, by the way, we are like discussing in our working group, like trying to identify metrics by which we can measure the progress. Like in the case of data cleaning, it's like, for example, accuracy improvement. All right, here is our website. If you are one of those folks who are doing research in the data-centric AI community, here are the place to go to take part in our challenges. Let me show you one of the challenges. For example, Vision Data Selection Challenge. All the information you need for being able to start taking part in this challenge is on our website, dataperf.org. You can go and learn about the rules, evaluation techniques, how to participate, the timeline. And once you're ready, you can just go to the submission site. And if this works, this will take you to the Dynabench platform. Dynabench is the platform that we have leveraged to build our data-centric AI challenges. This is one of the challenges. We have had 4 new submissions just over the past 3 weeks since we opened the challenge to the public. Yes.
Rail things, but I have no idea. The goal is to take a training set and make a smaller training set that gets the same quality of results.
Or same quality of results or even better.
How much smaller can you make it in practice? Are we talking a factor of 2 or 20 or 200? And how much do you think in an ideal world, if everything was perfect and you did a perfect selection, how much smaller does it get? Because I have no idea the order of magnitude.
The question is that, for example, when it comes to data cleaning strategy or data selection strategy, what's the limit at which we can reduce down the data volume if we go about improving data quality? I think the answer is it depends. It depends on the context. And the way we are designing our challenges right now is that we are giving a budget to the submitters. We're telling them, hey, we want you to come up with a solution that can solve this problem within this limited budget. So we gave them, like, I think the challenge we've designed right now, we gave them about 1 million data points. And the goal is for them to come up with a solution with 1,000 samples. So reduce it down by a factor of 10. But in the next iteration of the challenge, we might actually play with that constraints. If it turns out it's a very easy solution, then we're going to go for lower bars. Okay, so, and this is just like some timeline window information. If you're interested to take part, these challenges are open right now. They're going to be open for 2 months, and we're going to announce the winners at July 28th at ICML 2023. All right, just some interesting statistics. So the challenge has been live for only 21 days. Okay, so we have basically 2 platforms, right? DataPerf is the landing page. If you want to go and take part in our challenges, you go to dataperf.org. Once you're ready to make the submissions, we will be directed to dynabench.org. And so these are the statistics that collected collectively from DataPerf Dynabench. It shows that over the past 21 days, we had about 40 visits per day. It peaked about 50 people around the week after the launch announcement. And so far, the submission hasn't been that great, or involvement hasn't been that great. We have only 4 submissions for Vision Challenge, 3 submissions for Debugging Challenge, Speech and Acquisitions. We're still waiting for submissions to come. We are expecting maybe most of the submissions comes along the deadline, and we'll see. We need your help to spread the word. And if you know someone who is working on the data-centric AI competitions, please tell them about these competitions and let them decide if they want to take part. So what's next? So this is the questions that we just launched. So this is like an open questions that right now we are discussing in our working group. But at high level, our goals is to first make sure that these challenges are successful and we get enough participation. But we are thinking about the next steps. When we think about next steps, one is to make sure that these challenges that are launched right now are going to have a next iteration. And also, if you remember, I showed that breed of data-centric tasks and domains. It's very right now sparsely populated. We are like trying or striving to fill up more cells in that space. So if you are working in a data-centric space and you are interested to host your challenge, please come to our working group. We are trying to expand our portfolio of data-centric challenges. And of course, we are a research group. We are striving to publish our findings and results. The caveat to the fact that we are just a research group is that we don't have so many industry representations in the room. Most of the people who are there are like either academic folks. Yes.
I have a question about that.
Yes.
Yeah, I'm from the industry. I'm a researcher by the industry. And most of our data is either time series data or tabular data. So I find it hard for me to work on these problems because my data is still different.
Is what?
It's different.
It's different.
Yeah. It's either tabular data or time series data.
So tabular data fits the type of data we are already working with. But time series data, we are lacking, and we actually like someone who has access to time series data to come and propose how to improve the quality of, for example, time series data. You might want to tell, maybe it's offline, tell me a little more about the type of data quality problems you're facing, and maybe we can work out some collaboration.
At this point in time, my question doesn't make any sense because indeed we have kind of like sparse submission metrics, right? Adding more types of data, it doesn't really make it any better.
I think the more is merrier. If we have different types of data representation types, that would be better. Like one of the things, for example, is missing in our current. I mean, that was the one we identified through discussions that, hey, all of the data sets we have already are like supervised learning data sets. We don't have any unsupervised learning data. How can we improve the unsupervised learning data set quality? So like tabular data versus like time series data, that wasn't on our radar. If we had you in our research group and working group, that would have been part of the things that could have been on our roadmap.
I also think we should expect submissions will be blank paper submissions. So, raise your hand if when you were a graduate student, you submitted papers several weeks in advance. I actually think it's a good sign that you have 7 submissions at this point in time. That's
really? Okay, good to know.
I'm one of those.
Thank you. So yeah, if you are in a startup that's working on data-centric AI topic, please join our working group. We really want to have some people from data-centric AI startup world who are working on similar problems to come and take part in these competitions and show that who is better than who, really. Like right now, everyone is making their own claim that we are the best in cleaning the data, but no one comes and take part and show that actually they are the best.
This is interesting to think about what the direct economic implications of better data selection, for instance, would be on training costs, right? You know, David was just talking about
That's true.
the power footprint of training, right? If you can directly reduce the size of the data set without significantly impacting quality, right? You directly reduce that footprint, and that footprint is well correlated with compute costs. So there's some fairly big benefits to be had if we can get better at this kind of science, and it is amazingly understudied compared to the amount of time we spend looking at 0.1% increments on models.
Other things too, just like a faster iteration, you know, maybe time to market, you know, more that
Exactly.
researcher productivity, yeah, a huge bunch of benefits to getting to smaller, higher quality data sets.
I think one other thing that's missing is that, like, yeah, we can reduce the training cost. It comes at the cost of like improving the training quality. So how does the training quality improvement cost compares against the training cost? It's like those are like the trade-offs that are not really good to understand. It's not well understood still in the community. All right. So I think I said most of these things. Just join our working group if you have a data-centric challenges in mind to take to form. If you are already working in one of these domains that we already launched, please participate or spread the word about it. And if you want to just stay in the know what's happening in our working group, join our Discord channel. Thank you.
All right, so that brings us to the end of our talks. Everyone who joined us virtually, thank you for taking the time to join us. I hope you appreciated the working group update, the showcase on the Power working group and the DataPerf working group. We'd love to get your feedback. We may send you a feedback form later where you can throw rotten vegetables at us or sing our praises while throwing rotten vegetables, you know, whatever works for you. Hopefully it was a meaningful and enjoyable experience. And what we are going to now shift to, the format is to now have live in-person discussions. Unfortunately, wanted to focus on interactive exchange, which makes it really hard to include our virtual compatriots, unfortunately. So I think with that, we're gonna thank you all for your time. And again, please reach out to me with any comments. If any of the working groups caught your attention, if you have suggestions you want to make, if you want to get involved and contribute, you think you should be active, I believe the contact information of many of the working group chairs is there. And if it's not, it is certainly available on our website at the working group web pages, or shoot me an email, david@mlcommons.org. So thank you again for joining us virtually. I think we can close that down, and then we can discuss the in-person logistics for the super secret meetings that are definitely on the schedule.